Welcome back, Laker Gang. I truly hope you enjoyed your spring break, but now it is time to get back on that old grind. So, we are going to be finishing our book out with section 9 or chapter 9.7. So, how can you write and graph ordered pairs on a coordinate grid using two numerical patterns? Well, we have two patterns and then we have an x-axis and a y-axis. So, pretty straightforward what we do with those two patterns there. We measure one on the x-axis and the other on the y-axis. And the reason that we do this, one, it gives us a nice visual representation of those numbers. It's easier to see and understand. But two, we can use that graph to make predictions, just like we can use the rule to make predictions. So, first things first, let's read our question. Sasha is making hot chocolate for a party. I know it says cocoa, but I like chocolate. Sue me. For each mug of chocolate, he uses, he did not expect that twist, but that's cool, uses 3 tablespoons of cocoa mix and 6 fluid ounces of hot water. If Sasha uses an entire 18 tablespoon container of cocoa chocolate mix, how many fluid ounces of water will he use? Well, we should be able to tell that this is going to be a pattern. It says for each mug he uses 3 tablespoons and 6 fluid ounces. So, how many tablespoons of cocoa mix or chocolate mix do we add for each mug? We add 3 every time, and we add 6 ounces. So we can actually just go ahead and do that. We can fill out our pattern. Add 3, add 6, add 3, add 6, add 3, add 6. And that actually is going to give us our ordered pairs. We see down here at the table that our x-axis is going to be cocoa mix. Our y-axis is going to be our water. So we can go ahead and fill those in. So we know we are going to be working with 612. We're going to be working with 918. We're going to be working with 1224. And we have one more that we need to figure out. We need to figure out how much water there's going to be if we use 18 tablespoons of the chocolate mix. So, let's move on to that next part. We need to find a rule that we can write. So, how does that chocolate mix relate to the water? Well, to get from 3 to 6, from 6 to 12, from 12 to 24, each of them, we are multiplying tablespoons by 2. So if you use 18, we multiply that by 2 and you'll get 36. Now let's look at what happens whenever we graph these. We have 3, 6. We have 6, 12. We have 9, 18. We have 12, 24. And of course, we also have 18, 36. What you should notice is that makes a perfectly straight line. Don't let me and my crappy art skills fool you. It's a perfectly straight line. Anytime you are dealing with a pattern, because it changes by the same amount every time, a sequence, it's going to be a perfectly straight line. And here's how that's a good advantage for us. We can look at that and we can predict how it's going to grow. It's going to continue to go up that way. So maybe we want to know how much it's going to be whenever we used 15. Well, we can look right there and see 15 go up, and it would be 1530. And if you check our rule, tablespoon times 2, 15 times 2 is 30. So not only does it give you a visual representation when you do this, but it kind of shows you what it would be even if you haven't quite predicted those numbers yet. Alright, and we kind of answered that bottom question right there. We wrote down the final number pair as an ordered pair. We didn't actually do that. Let's go ahead and write that. It was 18, 36. And then it forms straight lines because it's a constant pattern. So, let's keep on doing this. It's actually probably easier than the last few lessons you've been dealing with. I'll do a couple more with you all, and then I will toss you out on your own for those down there. So, let's actually do this one together. Each $2 bag of copper wire contains 6 meters of wire. Write the number as ordered pairs, graph the data. So, they've already wrote the numbers for us. We can go ahead and write down the ordered pairs that we have though. We have 2, 6. We have 4, 12. We have 6, 18. And now we have 8, something. So, now that they filled in the chart for us, that first step is done. We've wrote down our ordered pairs. Now we just need to see what the rule is. Well, what are we doing to our x-axis to get our y-axis? To get from a 2 to a 6, to get to a 4 to a 12, you have to multiply by 3. So, whenever you have 8, multiply that by 3, you get 24. So whenever we graph these out, 2, 6, 4, 12, 6, 18, and 8, 24. And yet again we see that we have a perfectly straight line. That line just goes on forever. So, pretty simple stuff. I'm pretty sure that you all have got it down. We will do these really quickly. And the best way we can do it, they've already written that out. So like I said, go ahead, write down your ordered pairs, then find your rule. So I will go ahead and do these with you. It's a little bit wonky on my screen, but we've got 2, 8, 4, 16, 6, 24, 8, 32. So we can go ahead and write down those ordered pairs. We've got a little ahead of myself there, but I'm pretty confident you all know how to write those ordered pairs. You write that x-axis first, then your y-axis. I know that this little section right here looks a little wonky on my screen. It should look fine in your book. But let's go ahead. We've got those ordered pairs written down. Now we need to find our rule. So, if we're going from 2 to 8, from 4 to 16, from 6 to 24, we should realize pretty quickly we're multiplying by 4. So if we just continue that pattern, we multiply 10 by 4, we get 40. So you can go ahead, we can graph those out. 2, 8, 4, 16, 6, 24, 8, 32. Have 10, 40. We draw our line. It is looking straight. It's looking crisp and mint. Fabulous. Over here, we've got Mary's map. 2 inches represents 10 miles. Nice. So, we've got all of this. Now we need to find our rule. Well, looks like we go from a 2 to a 10, a 4 to a 20, a 6 to a 30. We are definitely multiplying by 5 here. So, whenever we multiply by 5, 10 times 5 will give us 50. So again, all we have to do now is graph 210, 420, 640, or excuse me, 630. We've got 840, and of course 1050. And a perfect straight line to boot. Look at us go. So now I want to see you all get these done on your own. I'm going to cut you some slack. Number 3, it didn't give you a grid for some reason. I'm not going to worry about you having to draw your own graph for this one. I know it's a lot of extra work. So, what I want you to do is figure out that rule. Figure out what that rule is and figure out what that final thing is going to be. And then you can write down your ordered pairs. Number 4, however, you're not so lucky. You're going to have to graph still. So I want you to go ahead, figure out those ordered pairs for each of those numbers. Then figure out the rule and finally graph it all out for that one. You all can go ahead and get started on that. Alright, and hopefully we got something similar to this. So, 2, 4, 4, 8, 6, 12, 8, 16, and finally Filling in our blank is 1020. And our rule is just multiply inches by 2. Down here, I'm sure you all did well. The only thing that might have thrown us off is our map was not going to be exactly on the lines for some of these. 15, 45 are going to fall in between two separate lines. However, I'm sure that we figured out that not only was our rule multiply minutes by 15, but that each of these points, even if they weren't exactly represented on the y-axis, they just go in between. 15 is halfway between 10 and 20. 45 is halfway in between 40 and 50. So good job with that, gang. Now finally, we've got a bit of a conundrum here. We are comparing two different hot sauces, or excuse me, two different chili recipes to find out who has the hotter chili. We have George and Lou. And as you see, the farther you go to the right, or the farther you go on the x-axis, the more chili you have. And the farther you go up the y-axis, the more hot sauce there is. So we can kind of guess it's going to be hotter. So if we read this, and I'll give you all the chance to read it, it says that we are supposed to write related number pairs as order pairs and then graph them. Then use the graph to compare who has the hotter chili. They've already done that, but what I'm going to tell you to do is double check their work. Because down here at the bottom it says Elsa said that George's chili was hotter than Lou's. Because the graph showed that the amount of hot sauce in George's chili was always 3 times as great as the amount of hot sauce in Lou's chili. Does her answer make sense, or is it nonsense? So read through there, figure out what you think, see if their answers are correct, and then explain why or not Elsa is correct. So I'll give you a second, pause the video here. Alright, so hopefully you all actually agreed with Elsa. I know that we're used to people getting it wrong in the book and we're having to fix it, but if you take a look, she's right. Whenever there are 2 cups of chili, Lou has 2 tablespoons of hot sauce. George has 6. That's 3 times bigger. Whenever we are talking about having 4 cups of chili, we have 4 tablespoons or teaspoons of hot sauce for Lou, and we have 12 for George. That is 3 times as great. And you can actually even use the points that they did not match up on. Like, let's say whenever they had 1, we would fill that in right there. 3 is 3 times bigger than 1. So 3 is 3 times bigger than 1. Maybe you want to check where they said 3. Well, at 3 cups of chili, she would have had 3 teaspoons of hot sauce, where he had 9. We can just keep following this pattern, and we see that every single spot on the map, on the line chart, George's chili is always going to be 3 times hotter than Lou's. And we can see that line is going to continue out this way. George's is going to continue out that way. It's just going to always be 3 times as great. So, good job, Laker gang. Pretty quick and easy video to get us back into everything and to finish off this book. So if you have any questions, feel free to shoot them towards me. You can put them in the comments, you can email me, you can dojo message me, whatever you need to do. Just let me know, but I bet you all can handle it. Alright, thanks for tuning in and have a great one.